right, ICS2O folks, our second day on touring, or our second lesson on touring, variables and data types. This time I don't think we have any pictures, so you don't necessarily have to be in Smart Notebook. You could be in whatever word processor that you like. And here we go. A variable is a location in memory used to store information. Kind of like in math, right? In math, we think of x's and y's as being variables, and that's very similar in Turing. Um, Types of variables. The thing is, in Turing, we saw just like we can output numbers and messages, when we use variables to represent these things, they have to be of different types. Okay, so we could have integers, which are no decimals, but they could be positive or negative. So when we use an integer value, there's no decimals allowed. We could have real numbers. If it's a real number, then we would have decimals. Well, why wouldn't we just make everything real numbers, and then it's okay if it has an integer or not? Well, as it turns out, and you don't have to worry about this, but real numbers are stored differently and usually in much more memory than an integer. So it's an easier thing for the computer to do, is to handle integers rather than real numbers. Strings, words or sentences. This is our hello world messages. Message are what are called strings. The reason why they're called strings and not messages or words or sentences is because they are a string of characters, and the strings can be letters or numbers or spaces or special characters or whatever. Strings. Variable name, rules. And we'll see examples here soon enough. But variable names must begin with a lowercase letter. They may contain letters, numbers, or the underscore, but may not have spaces, tabs, or special characters in them. And if there are more than one word, each extra word begins with a capital. So notice num of words, the new words begin with a capital rather than having a whole bunch of small letter. And by the way, this is called camel case. It's a funny word for it, but a camel case is like, okay, it's going short, and then there's a bump, and then there's a bump. It's like a camel case. And that's sort of in the place of using spaces. We use num of words like this and camel case. Doesn't have to be, but that's a convention. Is that it for this one? Yeah, okay. Again, remember, if I'm going too fast, you're pausing. Hang on. You must declare a variable before assigning values. So there's two parts to using a variable. One is a declaration, and one is an assignment. Okay? And you have to have this, the declaration, before you can have the assigning. And we'll see what this actually looks like in Turing in a minute or two. But remember, declare, then assign. Variable declaration is setting aside space in memory and giving it a name. So that's what it means to declare a variable. You set aside a space in memory and give it a name. So example. So this one here, var n :int. And notice that there's a comment telling us all about that integer. So it declares an integer called n. Var is a keyword, n, and then colon and int. And so in Turing, I think I still got my old hello world program here. So this is variables and data type. A25-ish. And so I'm going to delete all that. And then I write var. Notice that that's a keyword. It goes bold. N int. By the way, this variable name isn't very good. That's not very good programming style. If it's going to be a number, call it a number. If it's a name, call it a name. Just n isn't very good programming style because it doesn't read very nicely. But this is a properly declared variable now. it's an integer, and it's properly declared. Notice that it doesn't have any value yet. If I were going to go put number like this, it has no value. That's because I haven't given it one yet, but that's later. So let's see some more examples. Notice that I can put two variable declarations in one line. So x and y declares two integers called x and y. That's all in one line. So that's two variables, one line. Var area colon real declares area to hold a real number. So if I wanted to have decimals, remember then what I would want. And by the way, I put all my variables in one spot together for the whole program. And I call that a real. And real is a keyword, and now Turing knows these are what I'll call the variable declaration section of my program. Good. Var name string declares name to hold a word or a sentence. That's a string of characters, right? So string is another keyword, and it's another key type in Turing. So if I call name string, it realizes that. Notice some of the spacing looks weird. If I press indent, the indent button is an awesome button because Turing will sort of space it out so it looks nice. Okay. Is that it for this? Oh, assigning values to variables. Aha. We wanted to do that because we wanted to put out the value of number, but it didn't have a value. So it says colon equals means to assign or store. So here. Now if I wanted to assign, so I'm going to, this is my processing section. And I'm going to make number equals 34. Notice right now there's a, did you see the bug? Right there, I need to put colon. Colon equals 34. And then if I put number, this is my output section. We talked about IPO, right? Input, processing, output. Well, we don't have any input really yet, just a processing and an output section. And there it is. And how would I do strings? Well, I do the same way, except for I put the name inside quotes. That shows that it's a string. Oh, I didn't put out here. Let's put the name and then Ferd's number, name and number. And it's kind of smashed together, right? Well, we'll have to worry about formatting soon, but if I put a space in there and then a comma, that'll look a little bit better, I suppose. But I could also use that fancy colon business if I wanted to make it a little bit more spaced out. So say if I wanted to put that number in 5 spaces, there, maybe that looks better. Maybe that's the way I want to do it. And again, you get to add some of your own personal style with your own programs as long as it looks fine. I think I have some examples. So n colon equals 17 stores 17 in the n variable. So when we declared n up here, that set aside some memory, and then this thing fills that memory spot with 17. There's another variable assignment, as long as x is an integer. Y colon equals 12 plus 34. Well, it actually does this calculation on the right hand side. It'll do that calculation and then assign it to y. Well, how do I know that it will? Well, watch. I'll show you. I'm going to put var y as an int, and down here my processing, and I'm going to put y equals 12 plus 34. It's going to actually calculate that for me, and then I'm going to put y. So it had my output from before, and then it actually calculated that, and 46 goes into y, just like the note says. This is a neat thing. N colon equals n plus 1. In math, by the way, if this was math class, that statement there is a little bit, it's silly, it's stupid, right? Because if we were trying to solve for n, we'd subtract n from both sides, and then we get 0 equals 1. And then we get a confused look on her face, right? Because what's going on there? Don't know. That doesn't make any sense. Well, that's not what it means in computer science. Remember, erase that. Boom, gone. In computer science, what this does, it does the right-hand side, then assigns it to this variable. So it calculates this, which was n was 17 from earlier, then adds 1 to that, and then puts it back into n. Okay, so I'll show you that. So the number I have here, I got number equals number plus 1. And then I'm going to output that number. So when Turing gets to this command, it calculates this, 34 plus 1, calculates 35, then puts it back into there. When it calls on it later, it's going to be the value 35. Bam, 35, just like I said. Oops. Get rid of that now. Name equals quotes FIRD. When assigning strings, put the value you want to store in quotation marks. So anything that's in between the quotes is a string. When we typed out hello world in our first program, that was a string. We didn't know that then, but it was. All right, onward. Input from the keyboard. This is where when it starts to get a little more fun to program, because we can start interacting with our programs. To get information from the user, the command is get. Remember to declare the variable first. So now we're going to have an input section. And again, this is just my exercises here, but I'm going to have, instead of, I'm going to call it, maybe I'll call it, because I had this name here. I'm just going to use this name. I'm going to comment out the name here, and then on my input section, I'm going to go get name. Right? Now if I run that, notice it feels like nothing's going on, but the computer's waiting for me to put in. And notice that it grabbed the name. Right? It got the name FIRD. It didn't get the second thing, so I wonder what happened there. Why did it just got it didn't get the space. It didn't get the whole line. So it put name in there and then printed that out, and there. I interacted with the computer. I used my own computer program. That's pretty cool. So example, var name string, what is your name? Put what is your name? All right, well, I'm going to see what that looks like, because this is just printing out a string. What does the 2 dots do? There's the get name, like I said, there's the get name. But if I put that there, it'll actually tell me what to do. What is your name? And now the cursor's right up there. It looks like I'm supposed to put in FIRD. There it prints out FIRD. If I run it again, rest all, just to show you that it's not FIRD anymore, it's actually rest all. And that right there, that what is your name business is an important thing. That's called a prompt, and it allows the user to know what's going on in your program. The little bit of text before we get info from the user is called a prompt. Another weird thing that I want to point out is the dot dot. The dot dot at the end of a statement, at the end of a put statement, keeps things on the same line. So in this program, when I had the dot dot there, that didn't return the character to the next line. It actually just got it kept the cursor on the same line there. And again, it's all about making your program look nice, or at least look the way that you want it to. If I took that out, what is your name? It looks like the cursor got conked onto the next line. It doesn't look quite right. It'll still work, but it doesn't quite look right. It looks like the cursor should be there, and that's what the 2 dots does. Okay, I think that's it for today. Oh, no, there's a little bit more. Constants. Sometimes you wish to have a variable that never changes its value. In computer science, this is called a constant. So, for instance, if you had like you're writing letters home and you're always using the words Northwestern Secondary School, and you just want to call that school instead, you'd make that a constant. CONST is a keyword in Turing. So up here, if I make a constant and I can assign it on the same step, or I have to assign it, Northwestern Secondary School, then if I put it out here, notice that if I put the two dots and put school there, that's my output section is going to have the name, the number, and the school all on the same line. So what is your name? Jorf? Okay, Jorf it is. And then there's the number, and then there's the constant. Notice the output doesn't look that great. I should have a space in there, but that's something that I would have to fix. And that's part of the fun and challenging challenge of programming is getting your output to look the way you want it. That indeed is it now, folks. So I think you've got a whole bunch of exercises to do. Remember to save your note in the right folder, and then on to the exercises.